I think we still have 2 more minutes.
2:15, right?
20.
Yeah, it's fine. It'll just, we can trim off the edges.
Okay. Good afternoon, everyone. It is my pleasure to introduce Pavan Kapanipathi. He's a research manager at IBM, and today he'll be talking about function calling. He's formerly Dr. Chet's student. I think he joined in 2016, right? Graduated in 2016, and
Yes.
yes. So he has several top conference publications, and so I'm excited to hear this talk. Go ahead, Pavan.
Thank you. Thanks for the introduction. Share my screen. Are you able to see my screen?
Yeah.
Good. Okay. As Kaushik mentioned, I was in Wright State University with Dr. Shet from 2009 to 2016. I have
Recording in progress.
Sorry? Oh, it's the recording in progress. Are you able to hear me?
Yeah, we can.
Yes, we can hear it.
Yeah, I've paid my dues in that lab, so I know how it feels like. Envious of all of you being there. Just a bit more of introduction. Semantic web. I worked on social media based, knowledge graph based recommendation in social media. That was my thesis. In 2016, I joined IBM. Worked on multiple projects, everything core to knowledge graphs and reasoning until now, until the last year and a half, where we started focusing on function calling. I have a team of 8 to 10 people who are working on function calling, reasoning, and synthetic data generation. Given that, as I mentioned, the last year has been on function calling, and I'll just touch upon what we did and where we are and what's the domain of function calling and why it's important. Right. So why is function calling important, right? More and more, the use of language models are coming up. We are also figuring out that how does it do with real-time information? How can enterprise applications be integrated with these language models? Are there issues with reliability? If we have to improve reliability, what are the tools which are reliable that can be integrated with these language models? So it's able to call them. So multiple aspects of the limitations of language models can be addressed using tool calling and function calling. And the tools can be as simple as a calculator or as as complex as APIs. Some of the enterprise APIs are very complex with its constraints and what are the kind of parameters, what has to be done to call them, right? So the goal is for these language models to seamlessly integrate with a bunch of these tools and functions. So now going into what is function calling, you have a prompt. The LLM should be able to call these tools and functions given in a specific format. All right. And one example of it is, it's a fairly simple example, but it's still complex enough. Is it likely that Alice needs an umbrella now? So the model should be able to invoke multiple different functions in a sequence, sharing information between those to make sure that it results or it conveys the appropriate message or the answer for the particular question, right? Here, the tool invocation looks at finding users by name, and then gets to the user location, then gets whether at that particular location. And there is no specific instance of call exactly this tool, but the language model should be able to figure out which tool has to be called in which sequence and what are the parameters which has to be shared. Right. Yes, the plan for the functions to call, what are the required steps, execute these calls and respond to the user. Those are the three required steps here. And this is just an example, right? I mean, this is complex enough and there are, I'll get to at the end, I'll get to how this is being translated to agents. Agents are pretty huge now, and every possible language model companies are in the industry are working on it. Right? But just going back to tool calls or function calls, this slide is probably 8 months old, and 8 months is good enough time in AI for it to be called old, right? Most of the industrial competitors for IBM are working on it. Right? OpenAI plugins, Google Bard, since the third quarter of 2023, after they came up with Gemini, the rumors are that they are trying to make sure that these models are well integrated with with specifically Google applications, right? Similar with Microsoft, all of them, right? I mean, Cohere, Claude, Anthropic, everybody is looking into how or is progressing towards how they can better their tool calling and function calling experience to make sure that they cater to enterprise audiences and also fix some of the major issues which LLMs are prone to. And please do feel free to interrupt if you have any questions. I think I'll be hopefully done in 30 to 45 minutes. So it'll be good to have an interactive session. So just feel free to interrupt and ask questions. Nothing much complex here, but it's a fairly interesting and important topic for industry. Now getting into enterprise-based function calling subtasks, what we realized is some of these tasks are very important and are being used by assistants across industry these days, right? One simple example is multiple API detection. What are the APIs? Given an utterance, what are the APIs which have to be detected? Given an utterance and the set of APIs, what are the APIs which have to be detected? Right. This is a fairly simple example. It's from a data set, and yeah, yes, booking restaurant and play music are the two APIs which have to be called. Slot filling. Slot filling is a fairly important important task, and it's quite unanimous in multiple different applications. You have to do this pretty well in enterprise applications. Given a conversation and a list of slots for a particular function, what are those slots? And each of these individual tasks, the model should be able to understand these individual tasks, not necessarily just calling the whole function. These individual subtasks are also important in its own way because they have to be modularized and called in different applications, which are not specific to just function calling. But function calling encompasses these tasks. Slot filling is one of them. You know what these slots are, and you're able to fill in those values for these slots. Sequencing, right? Multiple API detection. The difference we are looking at is in sequencing, you are also focused on the order in which the APIs are called. Oh, I think I should have skipped this, but I'll just focus on the first three tasks, right? In sequencing, it's not only about, oh, these are the APIs which have to be called, but these are the APIs which have to be called in exactly this order. And when you nest those sequences, you should be able to say that this API's output goes in, or this function call's output goes in as an input to the next function call. Right? All these three tasks were fairly important, and our goal a year back was, hey, these three tasks are important for IBM's products, and how are we going to work through these tasks? How would we enable language models to perform these tasks really, really well? And one of the other tasks is also next best action. This is also part of how you can, if you look at, uh, I think, is it Power Automate of Microsoft and Watson Orchestrate? One of the tasks they look at is, I know that we have these three APIs or these three functions to be called in sequence. What is the fourth one after these three? The utterance in the partial sequence is available. What's the output for the next one? These are, to put it, encompass everything. These are the four tasks which I'll ignore the personalized responses. I think this slide didn't complete it in removing personalized responses. But given these four tasks, we had to come up with a mechanism to train a model where all these four tasks perform really well. And this is kind of OpenAI plugins era is when we started this work. And to get to the approach, the first step, or where most of the work goes on, is how are we going to collect enough data to train the model? And data is, given the language models domain, quality data has become a big thing, even for, if you look at RLHF, or even the phases of fine tuning. If you look at a Llama paper, any domain, you'll see that at the end they have human annotations to just make sure that the quality of the data they are trying to provide is good to train a model. Given that when we started this, we wanted more and more data sets and these tasks for us, and we could opt for two different approaches. One is transforming the external data sets, or I'll start with the other one, the synthetic data generation. The synthetic data generation was very popular back then when we started. Have a large language model, which is really good, and get some prompts which describe the task you want, and ask the teacher model to generate the examples. And from then, synthetic data generation has grown significantly in a lot of domains and is being shown to improve the performance of large language models significantly, at least for the smaller models from the larger models. However, just looking at the API tasks, we thought, let's do a survey of existing data sets, pre-large language models, and the ML time, or even before that. Yes, sorry, second. Okay. A lot of human annotations were being done for coming up with data sets. It might be digital assistance, semantic parsing, entity extraction and linking. A lot of human annotation efforts had been done, and we got like, okay, yeah, let's go ahead and see which data sets at least are similar to function calling. And if we are able to trace back those data sets to one of these tasks. Sorry. And an example of API detection, right? The multiple API detection. This is a fairly good classification. You know, if you get good classification data sets, primarily, starting off with semantic parsing data sets, you can get a lot of them which are manually annotated. And that is where we began, right? We looked at transforming existing data sets to function calling data sets. And this is our paper, API blend. I gave the motivation on why we need this new data set. It's primarily because there was not enough data for looking at function calling in general, right? There can be an argument on synthetic data generation having some issues. If we, when we started this, there was Tool LLM, Tool Alpaca, and a couple of other papers, and we tried to go through it. One of the major constraints we had is most of these data sets were using GPT as its teacher model, and we were not able to use GPT. And even with the inclusion of GPT, I'll show at the end of this talk, or at least the API blend paper, there were issues with using these data sets to train, because as soon as you take them out of domain, start evaluating the model on out of domain data sets, it didn't work well, right? So this is the reason we created, API blend, and it's a fairly big corpus for tool augmented LLMs. It consists of 10 existing data sets where we transformed 6 of them, and 4 of them are off the shelf. We have over 190K data samples, and this is for holo function calling. And once we have those, splitting them into 4 or 5 different instructions, we had a million plus instructions, right? And these, any questions?
I do have a question. Can you hear me?
Yes, somewhat. I think, let me increase. Yeah, go ahead.
I'll just come closer to the mic. Hi, Pavan, I'm Megha. I wanted to know, what do these data sets look like just in general? More specifically, if you're addressing the subtasks for function calling, so for like multiple API detection, it basically boils down to a problem of classification. So do you have separate data sets for each of these subtasks? That's one. And second, how do these data sets look like?
Yeah, I'll get to it just in the next few slides.
Okay, sure. Thanks.
Okay, and these are from fairly diverse domains: digital assistant, semantic parsing, flights, restaurants, hotels. There are assistants to make sure that we call some of the existing APIs with the right parameters for flights, restaurants, and hotels. So those were 10 data sets. Now let me get to those 10 data sets. And again, when we are looking at API blend, it's not only an approach for training data. We collected all the data sets for testing tool-based LLMs, right? And that's the green part of the table, and the red part in the first column are the data sets used for training, right? And the training data sets are all, we also have the test sets for them, and that will be the in-domain distribution for evaluating. In the out of domain, we have 3, 6, and 9 of the data sets. So the approach we took to transform the 5 data sets are some of them needed language model assisted approach, where we use some prompts. I'll get to the details of what we did there. On existing API outputs, seek SGD and seek multivars. So all of these data sets were transformed to sequences. And that is something which was very important for us to get to the sequencing part, which was unique and didn't have enough data sets, right? And for the rest of them, seek AIISC, seek SNPs, seek top v2, and seek tool QA, we converted existing semantic parsing and digital assistance datasets into API data just by using rule-based approach, right? The off-the-shelf datasets are the rest of them, which we use for evaluation. Tool Alpaca, Tool Bench, API Bank, Tool LLM, all of them use GPT. So we just use them for evaluation. And for language model assisted approach, these are all conversational data with API calling, SGD, and multivars. What we wanted was the sequence part of the API calls and one single utterance, not necessarily having a conversation to call each of them, right? The data set looked like the human bot conversation. Hey, I need my savings account balance. You call the right API, get the balance, and show it to the human, and then the next set of functions is called. The next set of asks from the human is done. It's a conversational data set, and we wanted to convert this conversational data set into one single intent or one single utterance, which has multiple intents and a sequence of APIs that has to be called. And for that, we used a language model, and that's where the seek SGD came up. So we give the conversation, we summarize the conversation, and make sure that the summary actually calls each of these APIs, which have been part of the original data set. And all the original data set is human annotated. And the same original data sets, API calls with the parameters will remain. We have different filtering techniques to make sure that most of the data which are being transformed are pretty good, right? We don't generate any API data synthetically. It's all in the existing data set. Right? And for seek AIISC and seek SNPs, these are if I'm not wrong, I think datasets created in 90s with the BIO notation, which are existing for a fairly long time, right? And they have human annotated queries about flights. The parameters list are unclear. So there are a lot of work which had to be done just to make sure that we get the list of APIs, like the dictionary of APIs and their parameters and their types with this data set, and also transform it to sequence-based data sets, right? And for most of this, it's been grammar-based. And these are the two approaches which we took, and another grammar-based approach is seek top v2. While I have been talking about sequencing until now, one thing which I want to mention is having an order in which the APIs are called versus nesting of those APIs, because one API's output being part of the other API's input. That nested sequencing is even harder to get than sequencing. Most of the sequences which we saw in the previous data sets are, hey, book this flight and then book this hotel. So those can be considered as sequences given in the sequence with which the request has been asked. But until you get to nested sequencing, it's hard to say that it's a true sequencing problem, right? And one of the data set which we found was a semantic parsing data set where there was clear nesting of APIs. So an output of one will be an input of the other. And that's what we used seek.p2 for. And it's also a rule-based, approach for us to get to the data set. And very similar, there are tool QA, it's an evaluation benchmark with the query and final answers. There were no intermediate steps of which APIs have to be called. So we actually extracted the intermediate steps from the original data sets, which is tool QA, and made sure that the sequence of APIs which has to be called are correct based on the original data set. So all these 5 data sets encompasses, encompasses around 159,000 data points. That is the train set, and we evaluated quite a few of the existing models. Yes, this is the one. All right. We evaluated Falcon, Llama, Tool Llama, MPT, which is close to a year back for us. Like 9 open models. 2 of them were tool augmented LLMs. I think that is Tool Llama and if I'm not wrong, let's look at this. Starcoder, Flantify, tool augmented as Tool Llama and Links. Right. And the first, this slide shows the results on in-distribution datasets, right? The in-distribution of the 5 datasets which we used for training the model, right? And the best we found after fine-tuning each of these models was MPT 30 billion. Not surprising, the numbers are quite high. But one thing which is good to know is the second number, which is low, is actually the slot filling performance. Slot filling is, even with in-distribution data set, is not a straightforward task. That's something which we realized. And if you get into the enterprise setting, slot filling has a lot more complexities than how the outside external academic data sets look like, right? And when we look at out-of-domain distribution, what we mean by out-of-domain distribution is the models, when we fine-tune these, have not seen this data, right? Tool LLM, API Bank. API Bank is a pretty good data set. A lot of larger models coming out evaluate themselves on API Bank. I'll get to another BFCL, that is Berkeley Function Calling Leaderboard, pretty soon. That's another data set which people focus on. We've been collaborating with them for a while. So on these 5 data sets, we see that MPT 30 billion fine-tuned perform pretty well, even in comparison to the existing synthetic data generated, synthetic data-based models such as Tool Llama and Links, right? So all the models were tested with 3 short ICL examples from these data sets. So API blend as a data set, you can clearly see significant improvements in all of these models, whichever is being trained on. And this is the data set which we have used in Granite models, which is recently the Granite 3 model which came out. And now, since the data set is done, we'll get to the Granite-Function calling model. It maps to most of the things I spoke about just now, right? It has some low-level tasks. It's a multitask training. The low-level tasks are parameter value detection, function name detection, next best function, and some of the high-level tasks, which is more closer to the sequencing part, right? Function training, nested function calling, parallel function calling. There is also multiple parallel function calling if you look at Berkeley function calling leaderboard. And the datasets, it's API blend, which is transformed to all of these functions, and our hypothesis, which is pretty well founded, is in you train on these individual tasks, which are fairly simpler, and it'll work well on more complex tasks. Right? And with that goal, we transform the datasets to all of these individual subtasks for function calling, and trained our model. If you look at the distribution of the datasets which we had, I think Glaive V2 is another dataset which is open source, which we included. Excluding that, it's seq-std, seq-snips, seq-top v2, seq-atis, and seq-multivos. The table below shows what high-level and low-level subtasks does each of these dataset encompass. As I mentioned before, just seq-top v2 is the only one which has nested function calling, and that's something which we are working on significantly now to make sure that the models do better on nested function calling. The figure on the top shows what are all these tasks, the input and output format, which we focused on. We, instead of it being language, we transformed it to JSON. It's not unusual. I think a lot of like the chat template based formatting is being prominent in Llama models and other models too. The structured part of inputs and outputs is getting, will for sure become more important, right? The biggest challenge we had is to come up with the right training mixture generation, which has been fairly manual right now, just figuring out where it works well, where it does not work well, and fine-tune the model based on that training mixture. There are automated ways to come up with those training mixtures, but a couple of teams at IBM are looking into it in more detail. I think at some point that will get much smoother for us. And I mentioned that there were out-of-domain distribution datasets and in-domain distribution datasets in API Blend. In the recent past, there is Berkeley function calling leaderboard, which is evolving to evaluate function calling in multiple different dimensions. The first version of Berkeley function calling leaderboard has focused on simple API calls, multiple API calls, parallel API calls, multiple parallel, and they also look at, given a bunch of APIs, can we create Python or Java or JavaScript code to call those APIs with the right parameters? And this particular slide is probably 3 months old, 3 to 4 months old, which is also pretty old in terms of numbers. We were the best Apache 2 or open source model on that leaderboard. We were 4th best overall if you look at distinct models. This is after Claude, GPT-4, and Gemini. Right now, that's not the case because they evolved the data sets and the evaluation metrics, and Berkeley function calling leaderboard is constantly evolving and evolving for good, because function calling that helps models evolve their function calling abilities. We are evaluating on their V3. We have improved significantly in our performance and function calling over time. So excluding that, one slide which I've for sure missed is a slide on Granite. Granite is IBM's premier language model, and a lot of products inside IBM are using Granite. Granite 3 is what we released 10 days back. It's doing, it has a 2 billion version, 8 billion version, and much smaller models with a mixture of experts architecture, and it's doing as well, or in some cases better than Llama. And function calling has been one of the prominent places where we are doing well, right, in comparison to other models out there. So now getting to how good these, yes, any questions? No. Am I good with time?
Yeah.
Okay. So how much more time do I have? 250.
About 20 minutes more.
Oh, about 20 minutes more. Okay, got it. Thank you. So yeah, I think I'm almost done, so that's good. So, the 20 billion function calling model on out of domain data sets is performing pretty well, and the 20 billion model which we have is a fine-tuned 20 billion code Granite model, right? And this is accepted in EMNLP industry track with very good reviews. And these are, again, the same out of domain distribution benchmarks, right? And another proof point for exactly the same thing. They on different out of domain data sets, the API blend plus glide training on Granite works really, really well. Response detection, same. I'll skip through. Response detection is much more, very few data sets. Like API Bank has level 1 and level 2 data set, and those are the only data sets which had evaluation of responses, and this is based on language evaluation. So these numbers mean something, but also does not mean everything. Given that, we were on par with the 20 billion function calling model with the 70 billion MetaLlama instruct. Right. And one more metric which we wanted to look at is the hallucination rate. Hallucination rate is how many of these functions which we are calling are hallucinated, right? Are not part of the list. And we saw that given really good performance of these models of Granite 20 billion, the hallucination rate was also fairly low in comparison to other models. Right. MetaLlama, this is Llama 3, 70 billion does pretty well with its hallucination rate, the performance is not that great. Right. And this was our function calling model, which will be presented at EMNLP this year. And I can stop here for a couple of minutes if you have any questions. Otherwise, I'll go to what we are trying to do next. But it's the what next part is fairly generic.
So Pavan, I had a couple of questions. Maybe this will come in the what next part, but my question was around if you have a session, right? A chat session, like normally we do it when we log into ChatGPT. How does that affect how you're tracking the sequence of function calling operations? And the second question I had was, I've seen the parameters for these models be mostly multiples of 7, 35, 14, 70, and so on, right? The 20 billion seems, I no justification for it, so just those two questions.
Why was 20 billion considered?
Yeah.
So that's a good question. I don't know. I mean, kind of models do evolve in. It almost feels like at some point cars assembly lines. So models will eventually evolve to have there were 3 billion models. Now there are all 2 billion models. There were 7 billion models, 8 billion models. Now Llama is now coming up with an 11 billion model for multi-model. So not found any clear justification on why there is a change in number. I think we picked 20 billion because that was the model which was trained with Granite. Would
Okay.
that remain? That's a good question. But the code family models, the 20 billion, 34, there is also a 34 billion Granite code model out there. That's a good question.
Thanks. Yeah.
And yes, you're right. For the other question, which is based on conversational context, we are doing some work, and that comes with in what is next, right?
Okay. Okay.
Any other questions? If not, I'll move on. So this is the Berkeley function calling leaderboard. This is what the version 3 of the leaderboard encompasses. On the left-hand side, you can see that it's getting into multi-step, multi-turn. There is a lot of conversational context which will come into play to make sure what all has to be considered to call the API and how the responses have to be created for further steps and what will be the eventual goal. So the data sets are getting more complex, multi-step and multi-turn. And on the right-hand side, you will see the distribution of this is benchmarking part, right? Which also has the ability to drive how these models will be trained over time, right? Long context will play a pretty big role. Different languages will play a big role. Missing parameters, missing functions. When there is incomplete information in your APIs, how would the models handle the errors part of the models? How of the APIs, how they are being handled. This just pushes performance of these language models to get better and better and more complex on function calling. And this is an example, and this is the path where we are taking to, right? And when we are doing that, we'll also face more and more problems in finding existing data sets which can be transformed. So synthetic data generation pipelines have shown to all of us here will be familiar with that. They've shown to improve models' performance. Complex synthetic data generation pipelines will become more and more important. We created like 35,000 multiple parallel examples from this particular pipeline which we developed, and using those we were able to hit 5% improvement on BFCL leaderboard. This was BFCL version 2, not version 3. And similarly, we are trying to focus on more synthetic data generation pipelines for function calling. And the natural progression of function calling will be agents, right? And if the two most simplistic ones are one is fairly popular, React. These are agent-based prompting techniques. And the other one is Revo. Won't go into the details of what the differences are, but how can tool calling or function calling be integrated primarily with plans which include these tools and functions to achieve a particular goal, right? How are we getting there? What can we do? It's not just about function calling, it's function calling with a particular purpose and goal and step-by-step information about which function has to be called and for why. All this will get bigger and better now. That's how I look at it. And I think the rest of the slides are primarily that. But the React Revo, the agentic part, the reasoning part, okay, ignore the bottom part of the slide, but we are looking at how the reasoner, planner, code interpreters can help in generating synthetic data or transforming existing data sets to get to agentic behavior of these data sets. And that is it. We still have 10 more minutes for if you have any questions. The questions can absolutely vary from just the technical part versus how it was in Dr. Shet's lab for 7 years for me. Not, we are good to go, Kaushik. Oh, go ahead.
Yeah, so my question was kind of related to what Kaushik asked regarding the sequencing. So basically, is the sequencing or nested sequencing happening during inference time? So for example, if what he said, like in a conversational setting, if I want to update my sequencing, like initially the set of instructions were like, do this, do that, and then the third task. And the model does those function callings according to that sequencing. But then later the user wants to update the sequence or just, make insertions or additions elsewhere. Is that possible to do it during inference time? And how do you handle the dynamic updating of sequencing?
That's a very good question. The first step for us is there an evaluation benchmark for it? No. So have we created data to address that question? In some cases, for our product needs, we have. But evaluation for that particular task of correcting an output from user context has not been straightforward, right? So even if I say yes, yeah, we do it, or no, we do it, both has the same.
Yeah, no, I can imagine and like intuitively see what are some of the very apparent challenges of doing a dynamic update in something that you have already trained it on.
Because
that's
models do that, right? Models have the ability right now to actually go back in conversation context and make sure it picks one of the, like, let's book a flight on this date, and then you go back and say that, why don't you change it for XYZ? Models have the ability. Have we? Is there an evaluation benchmark for it? No. but yes, there we do create data sets for such scenarios.
And I have another question, and this might not be. So when you're doing synthetic data generation for curating your data sets, have you noticed any ups and downs in the hallucination rate when you are doing more synthetic data generation as compared to if you were using manually curated data set rather than going for AI generated data? Like, is there any correlation or causation between synthetic data generation and the hallucination rate?
We have not the performance, as I told you, for a particular set of tasks. Let me get back, take a step back here. So how are we generating synthetic data? We are trying to generate synthetic data knowing that these are the places where the model is not doing well, right? So
Yeah.
we are trying to add features based on synthetic data, right? I mean, one of the things, as I mentioned, was multiple parallel. That improves the overall performance of the model on those benchmarks. And that has happened multiple times for us, but we have not looked into if that has impacted our hallucination rate. Again, that's a very good question. We'll try to see how that would have changed.
Okay, thanks. Great talk. Thank you so much.
Thank you.
Two questions from my side, actually. So there are several providers available here. Again, someone is calling us function calling, and someone is calling us tool calling, right?
Correct.
Are they two different, or are they mean same thing? And the second question is about, I think Mega asked this question a little bit. So how does it, when user asks this question, we need to understand the intent, right? Based on the intent, we go ahead and select the, like say, 2 functions calling or 3 functions calling, for example, right? How does the planning happens? I think in GPT, they use something called planner as a concept.
Correct.
And how does it work here in terms of the Granite function calling?
Okay. The first question was the second one, as I mentioned, it will go towards the agents part, right? I mean, how the planning has to be done and what are the step-by-step stuff. And if we look at even how this trajectories or the planning part has to be trained, that's an aspect of work which we are trying to do. But in the sequencing part of can we use a planner as for different constraint-based verification of those sequences? Absolutely. But excluding that, for now, since we are focused on model building, we've not looked into the planner, I mean, like the traditional planner aspects here, right? And sorry, what was your first question?
Function calling or the tool calling?
Oh, the
Is
difference
there
between tool calling and function calling. We look at some papers, I mean, the distinction has not been straightforward. But the latest Llama paper, which kind of goes with what we've been thinking, is search, Wolfram Alpha, and code interpreter is being considered as tools. You kind of train these models differently for it to learn how these tools, I mean, there is a default setting how these tools are used by the models, versus custom functions where you give these functions in the prompt and you're training to use any of those functions, correct? That is where the difference kind of has been. They call it like zero-shot tool calling versus few shot, or default integrated tools versus custom tools. Yes, for training, you can make it very good for a certain set of tools which you feel which we think would be interesting, and you can also train them for them to be like good with just random custom tools, right? Both are important, but that's the distinction I know of.
Sounds good. Thank you. Great session.
Cool. Okay, then 3 minutes out. That's it. Thank you. Thanks.
There's one more question.
Oh, sure.
I just had a quick question, Dr. Jimini. As far as security is concerned, what kind of security measures do you have since these are API calls? Will it kind of follow the same system that current LLMs are following as far as securing user data and maybe secure calls, externally? What are the security aspects that you guys have in place for this?
That's an evolving field, and we have a large team working on it, right? Both, I mean, like not only API calls, like even Python interpreter, right? Yes, the LLMs can come out with code. Do you really have to run this code in a real environment, and what's the consequence of it? That's an evolving field. IBM has a large team working on it, and for now, with the kind of data sets which we have, these APIs have not been real APIs, right? So that's how we trained it. So it's in the context of training, it's not a big deal, but if in the context of using the model for these tasks outside, yes, it is a big deal, and there has to be the right standards and the security concerns addressed to make it work.
Yeah. Thank you for answering my question.
Cool. Thank you. Thanks, everyone.
Thank you.
Thanks, man. It was a great talk. Thanks. Okay.